Let me do this. Welcome, everyone. This is our September edition already of the OpenLineage Meetup. So we try to have those meetup monthly, either OpenLineage or Markets Meetup exchanging, and it's been traveling. So there's no unique city to it. We had it in San Francisco, we had it in New York, we had it in Toronto now, in Providence, and there'd be more. I think there's a London one planned, and is there one in Warsaw as well? Anyway, welcome. Please sign up the sign-up sheet so that we know who attended, and we can let you know about the next one. And so today,
maybe just a second for the so there's going to be pizza delivered and some soft drinks coming up. And there's make sure that there's beer, cold beer, wine beer. They can make
and yeah, so we take a break to eat when the food comes in. And so there are several interesting topics today. And then we'll make sure to take a break and mix it up. So first, I'll do a quick introduction of what's been the vision for OpenLineage and where we've been so far. And then we have several topics that go into specific details of current things that are in progress. So quickly, I'll go through looking what's the OpenLineage vision like in 2 minutes. What was the plan and growth of the community and so on, where we are so far, and a little bit on next steps, and then we go into the more interesting talks of the day. We have the folks from Metaphor who is going to talk about what they've been doing from OpenLineage. With OpenLineage, Metaphor is a data catalog, but they'll tell you more about it. And then we had some things about the column level lineage and OpenLineage in Airflow discussion after. So what's OpenLineage? So there are lots of new faces. So I'll go a little bit like quick summary of what OpenLineage is for without going too much into the details. But feel free, if you have questions or we can talk over pizzas or something. Feel free. This is small group. Like this is meant to be a conversation, and feel free to interrupt, ask questions. If you want to stand up, say this is all bullshit, and like have a different opinion, this is okay. Don't do it too much though. Yeah, but maybe I should be careful. Yeah, like don't take everything I say literally. Like I'm going to get no rotten tomatoes or rotten eggs. So here we go. So OpenLineage is to define an open standard for the collection of lineage metadata from pipelines as they are running, right? Like there's a parallel between OpenLineage and OpenTelemetry. OpenTelemetry does that for services. And the goal of OpenLineage is to do that for all the data pipelines. So the best time to get metadata is when the transformation is happening, is basically the idea. So to standardize how we collect them. And so before, I should have made that slide. So I put some example of open source ones. We have more adoption now. Before, everybody had to go and reverse engineer all the data pipelines to figure out lineage. So there's lots of duplicated efforts, a lot of like unnecessary communication, and like it's complicated and it's a moving target, because since you reverse engineer and depend on the internal of like Spark and SQL and all of this, and every time those things change, then it breaks integration. And so there's a lot of effort in maintaining collecting lineage, and there's lots of duplication of effort. So the idea is we're going to put all that in common. So if everybody speaks the same language, we remove all the duplication of effort, right? Because each producer of lineage can produce lineage once in one language. Each consumer can just understand one model, simplify the whole problem. And especially if the producers of lineage agree to a contract, it's not a moving target anymore, right? Like everybody agrees on the same contract. It's much more stable. It's easier. There's less duplication of effort, and we all win. And when we were like a couple of years ago when we were pitching the idea of OpenLineage, everybody like, well, why don't we have a standard already? Which we just need to get together and make it happen. Is the idea, right? So operational data lineage, as we've been calling it, is really about you have all the job that transform data, whether it's Airflow DAGs or Spark jobs or other things, or SQL queries, and they all transform data. And as they're running, we can collect metadata and collect it in a central metadata repository. And so this is an example. You have the OpenLineage spec, and you have a bunch of integration in various things. So again, those are kind of examples. The ecosystem has grown quite a bit, and we're going to go over that. And there's different type of jobs, whether it's streaming or batch or SQL oriented or data quality oriented, but they all can transfer metadata to various systems. And some people care about compliance, governance, some people care about data reliability, data quality, and they can use different tools, but have the same integration for collecting this metadata. And so I need to add more logos to this because if you're not on this slide, and you should be, like maybe the metaphor folks, maybe you want to be there. Please reach out to Michael or Ian over there, or any of those folks with a blue T-shirt that says OpenLineage, and we can get you there. And the goal is to grow this community that has been there. Oh yeah. Also, this slide has been updated. So see, we have the metaphor here. So it's kind of thinking about producers, which are on the side of producing lineage and sending OpenLineage metadata. So there's a bunch of from SQL to Spark to Flink to Airflow, DBT, all this data ecosystem, and open source and proprietary things. And on consumers, you have things like Purview. Egeria is a popular open source project. Marquez, which is a reference implementation for OpenLineage. Data catalog like Atlan, Metaphor. Astronomer is focusing more on data reliability aspect of things.
Where does Google go on that side?
Both sides. So as of 2 weeks ago, Google and Google announced that they're supporting OpenLineage at the Cloud Next conference. And so on this side, you have Dataplex, which is, I need to ask for permission to add the logos over there. Dataplex, which is your data catalog. On the other side, you have Dataproc. So if you run Spark in Dataproc, you can send OpenLineage. So they're on both sides, and I believe there'll be more coming.
I cannot officially speak of it, but there might be.
There might be. So if you stick around at Airflow Summit, you might learn more about this. And so, yeah, but that's fairly new. So the plan, right? How do you create? So we didn't have, like a few years ago, we didn't really have a standard to collect lineage and make this thing where everybody can consume lineage. So how do we achieve this? So first, we started with reaching the community. So the first slide you saw, the community, like reaching out to people who care about lineage in the community. How do we get together and bootstrap this spec, right? If you want to start a community, you want to start with a decent number of people. So we are saying you're doing a standard, you need to actually build consensus across a group of people. So starting with a core spec, and we made it as small as possible, right? One of the design of OpenLineage is to make it like a core spec that's small and very extensible. So people who care about compliance, column level lineage, other things, they can focus on those things through facets. So there's this notion of facet, which allows extending the spec. And we can start from this small core, but it's easier to get to a consensus around, and saying there's going to be a bunch of small spec for facets around various domains, right? Whether it's compliance, data quality, performance analysis, all those things. And so after that, we bootstrap this with open source implementation. So doing an Airflow integration and Spark integration and DBT integration, all the popular open source projects, which, because we have this, it drives interest in consumers' data catalogs. So that's how, Microsoft got interested, Atlan got interested, Google got interested. And creating more support for consumers, right? So the fact that there's availability drives interest in catalog, and the fact that there's demand for catalog drive adoption for more producers, and like that's where the non-open source things. So it's harder to get extract lineage from all the things that are proprietary. You cannot look at the code and not look at side of them, right? So, and that's what drives this healthy circle. The more demands here, the more there's like it creates production of lineage. The more it creates production of lineage, the more it motivates other data catalog to implement. The more it creates demands, and and that's how we get to the snowball effect, right? So we're kind of in the middle of it at the moment. There's a lot more adoption from data catalog, which creates also incentive for other third parties. Like Fivetran is working on an OpenLineage integration as well, and there's like a few others. And so it creates this sales ecosystem. And so that's the evil plan, how we build an open standard and work together on it and being very open on extending that. So success so far. So we started from the open source integration. Oh, I forgot to talk about Marquez. Marquez is the open source reference implementation of OpenLineage. So OpenLineage is just the spec and the instrumentation. Marquez is an open source metadata repository when you can look at all your lineage, and usually there's a certain number of companies that are using it to build their own solution on top of it when they want to do so for compliance, whether in banks, in privacy regulation, and so on. We're success with early adopters, and there's names missing here. We need to update the slide. There's more. So thanks to early adopters, Nigeria project, the Microsoft Purview, talking with Snowflake, with Manta, and then more recently, Atlan in particular, Matthias and people are also been working on things, and we need to add Google on that slide. And on that, I'm going to leave Michael to talk a little bit, and I believe it's not talk a little bit about the growth of the community. So Michael collected some data. I can do the slides for you if you want.
That would be great. Thank you. And I won't take long to do this. I want to give another sort of valence on the momentum that we're experiencing in the project. And so I wanted to share some stats. These are from Orbit and GitHub and various sources demonstrating our growth. This is our more or less, straight line adoption, including Google and Metaphor. And if we go forward, we're also seeing similar trend line in terms of our membership overall. And this is from Orbit, which we use to track our numbers. Can't share, unfortunately, all of the members and users in the ecosystem. We're hoping to have news in the future from this one that's purpled out. But as you can see, we have growing critical mass. Here. I don't know if you can see from where you are, but we have Medium, Manta, IKEA, Google, 6.6 new adopters, Getting Data, our stalwarts, Astronomer, Intuit, the Cat Protocol. Similarly, this is a breakdown of our active numbers across 12 months. And yeah, I think that's good.
Yeah, and so that's my I want to convince people again, it's an exponential curve. So at the beginning, when you start a project, the curve it looks awfully flat. When you exponential curve at the beginning, actually, we can see this is really increasing. And the idea is, every time there's a new member to the ecosystem, like everybody benefits because it makes the ecosystem more valuable for every one of us that is part of it, and it creates more incentive for new people to join. Right, so there's like a really nice, healthy, virtuous cycle into growing the ecosystem and welcoming others and bringing them in. And the goal of this meetup is well, we all stakeholders in the project, right? I guess when you join the ecosystem, you become a voice in driving the direction of the project and contributing to it and making it the right thing. So, and yeah, next steps. I think one thing that was done recently was moving the OpenLineage Airflow integration into Airflow itself. So that's a big change. That the goal of the spec is to just be a spec. So of course, as part of the project right now, we also have the Airflow integration, the Spark integration, filter. So we don't have the Airflow integration. We still have it for older version of Airflow. But the Airflow integration is now moving to Airflow, so that it's going to be a lot more stable. Because instead of extracting lineage from the outside, from the internals of each operator, that was easily broken from one release to the next. Now it's part of each operator to expose the lineage. It makes it a lot more stable, makes it a lot easier to maintain, to test with the operators. When someone changes something in the operator, they test the lineage at the same time, so we know it's going to be stable. Makes it a lot easier for people who write custom operators to support lineage to have built in. And it gives an example for all the other projects that we've done, right? Eventually, you'll be able to move the Spark integration into the Spark itself. That'd be great. But you know, it's not something we can decide. It's something that the community needs to get together and agreement to this. And so the next step on that is to make some more support for lineages, things like Python operators. And so there's a discussion about working with hooks and things like that. So, yeah, so, and that's it on this part. And the next presentation is, so, but, you know, so I give you a community, if there are questions, I'm happy to answer questions. And otherwise, Metaphor is going to show what they've been doing with OpenLineage. Any questions?
Are there any alternatives to OpenLineage?
Alternative to OpenLineage. So I don't think there's any independent alternative. So there's several data catalogs who provide their own extractors or lineage collector things that works with their data catalog, right? There's no alternative that I know of to OpenLineage. In the Spark ecosystem, there was a project called Line, which also extracted lineage from Spark and had different things. But really, OpenLineage has become more the reference, I think, in that domain. And it's the only thing that's kind of everybody can benefit from, right? The idea is when you choose a data catalog or a data lineage product, right? You have to put a lot of effort in making sure all the lineage comes into it. And so it has set of features and you have to pick, right, between compliance and governance and data reliability. But with OpenLineage, you really get yourself a lot of flexibility into collecting the lineage on one end and like plugging in various products like on top of it.
Right.
And
there's some investment getting it into the format.
Yeah.
But you benefit because you solve the consumer producers, right? It's not like you're doing it, even if you're doing like an in-house system and then realize maybe you're going to buy a catalog or vice versa, you have a catalog and then realize you're going to do more with it. If you haven't been able to format, then you've already done the investment and work to get it to work in that format, so you can switch your providers as well.
Given the proximity you have in playing with Google with data flow, anything that actually limits project engagement in this, they have metrics. It would be nice to have data information part of it.
It'd be nice. We'd love to do this. So so it's sometimes the bandwidth is limited by how much. At the beginning there was a lot of the core OpenLineage people doing outreach and say, hey, let's integrate with this, let's integrate with this. As the project grows, right, I think there can be a lot more like inbound interest and not just us like going outbound. And so we love to collaborate with Beam. Sometimes, the number of things there are is kind of limited by how much we can reach out to people outbound and say, hey, do you want to participate in this? But as we grow, there's more things that are just happening on their own, right? Without, like the core contributor of the project, like kind of pushing for a collaboration. So I'd love to see more Beam integration. Right now we. Hmm?
Beam itself is kind of.
Yeah, it's an API on top of things. Yes. I think Beam would be great. Yeah, that's true.
Right, so then the question is, does anyone know somebody to be a champion?
You know, people have.
Well, I know that Steve.
Yeah, I think so. Right now we talk to data prop. We haven't talked to data flow yet, but maybe that's next.
Maybe that's a good way to push it. We use it a lot. I know that the Dataplex is not great because you trigger in data flow. And when you try to see the Dataplex, it seems the composer, but it seems like a GCS, which is created from the flag for the table. So every time you run that transformation, that's a temporary table, OpenLineage. It's like, that's not right. Yes, you use a temporary table to complete the table that was once. So there's still things that need to be checked. But yeah, definitely. I guess on our side, we can also push from the community, like, hey, have you seen these?
That's how it works. Yes.
Yeah,
Yes.
okay.
Yes,
Let's
both.
go with us.
I think both can work. And so actually, we're going to connect more with the Google folks. So and obviously Beam it's a community, and there's also like obviously.
No, I was curious because we have Link as well, right?
Yeah.
One of the runners, so we're like, okay, so it seems that is the runners might start developing capabilities, just a matter of having that much income. It's like, hey, we should make this a standard, just as metrics for a standard.
Yeah. That makes sense. So the Flink thing is happening because there's the big user in the community. There's a big user of Flink, and they say like, hey, we need a Flink integration, and that's what makes the integration happen, right? It's kind of like what the community needs that builds pressure and creates. Okay.
And you're also that.
Nobody wants to be first implemented because they're putting all the work in. But nobody else wants to do the last. So if you start with this curve, you start to see like Microsoft is doing it. There's another big cloud player that like I wouldn't be surprised if their next conference they don't be able to do it. No, but they're the kind of company that takes open source products, monetize them. So and they work on that, right? So like that wouldn't be a surprise because if you work for one of the three companies, they're always looking at like what's this cloud company do, what's that cloud company do. So it's an interesting early middle spot, I think.
Yeah, we're just in the inflection point. Yeah, cool. Okay, you want to come?
Probably also slides can see from and can we grab a chair? Yeah, sorry. Can we grab a chair?
Sure.
Great. Okay, so I need to share over this Zoom, right?
Yeah.
Oh yeah, that's okay. Would you rather a stool or I have to use a chair? I guess you're gonna stay there. It's what I for you. So you're gonna upgrade it. Oh, we can put chair here. Yeah, you guys gonna go and work. Okay. No, I mean this chair. This chair? Yeah, sure. I won't block anything.
Hey, hello everyone. Good evening. And today we are very excited to be here to show you metaphor. And in this presentation, we will tell you more about metaphor, and we will do a demo about the metaphor lineage. And during the demo, we will showcase how metaphor integrates with OpenLineage. And in the end, we will answer your questions. Okay, so let's first introduce ourselves. This is Ivan.
Yeah. Hello everyone. Well, my name is Ivan. I joined Metaphor since when it was founded, 2021 January, so almost 2 years since now. Working primarily on the UI, also was able to implement the initial stuff in the UI before. Yeah, I guess they also work with some browser extension for Chrome and for Edge. Yeah, very excited to be with us today. Thanks for
Yeah, and I'm a Ye. I'm also a fund engineer of Metaphor. I also joined in 2021. Yeah, I'm also compared from. So I make contributions to the web app and also a front-end tooling. I implemented the column level lineage because on top of the lineage graph I've been built for the Metaphor. Okay, so I want to ask you guys, like, how many have you heard about Metaphor before? That's great. Yeah, anyway, today we gonna tell you what is Metaphor. So Metaphor is a social platform for data, and it's a modern data catalog boosted by AI and supercharged by people. And Metaphor, it's the all-in-one place for your data-related conversations, where teams collaborate and innovate. You can also capture the institutional knowledge with posts and documents. And also you can easily search, share, and access the data details on Metaphor web app, Slack, Teams integration, and also, as I mentioned, a browser extension. So, at a Metaphor, we understand to enable people to have the meaningful conversation about their data. So they first need to understand, have good understanding about the data. So therefore, the Metaphor has many features to help user make sense of the data. Metaphor help users better understand the data with the comprehensive end-to-end lineage visibility. What does that mean? Later on, during demo, you will know. Yeah, and also recently, we introduced the OpenLineage to a Metaphor when we're trying to integrate with Spark. So why we choose OpenLineage? It's because, first of all, OpenLineage fast becoming the open standards of integration. Yeah, and it also has a very active community. So our developers get tremendous help from the community Slack channel, I think. Yeah, when we are doing the integration. Yeah, and also it has the industrial leading Spark integration. That's what we did. And also we are working on the Airflow integration, which is also coming with OpenLineage. So you will come very soon. Also, it's backed by Solomon, which is the company, so which gave us the big confidence to choose this product. Yeah, so like all in all, like we really love OpenLineage. Okay, so next, I will let my colleague Ivan to take you a deep dive into the lineage on the platform.
Okay, cool. Yeah, probably before we go for the demo itself, about the stage itself and more important. I guess everyone already knows what it's for. But let's go over again. So lineage, it's a reference to what's added of the data. It's a process of extracting information from the origin and how data transform when it flows through organization like line. And often that information is critical to ensure accuracy and compliance with the data, and also often it's required for regulatory purposes. It helps track in data validity and quality while ensuring compliance and governance of the data. But however, the management lineage can be challenging given data volume and variety of different data. So for our integration with OpenLineage, as Ye previously mentioned, we already have working cross-farm jobs, and Airflow is coming soon and might have in the future Flink integration. So everything else is architectural, wide-wise, it's consuming host requests from all the jobs and DAGs into lineage endpoint, and later on we ingest everything into our database. We're using like JavaScript, TypeScript everywhere, and use MongoDB for the database. So let's talk about code, show me some code, and I guess we can go over it and show some nice examples. So the main piece of our ingestions. So eventually what it does is has some authorization headers from event handler and have some tenants, basically a key for immediate port. We do some verification for an body, and the piece, the main piece, is a handle event. It's an OpenLineage data processor that actually helps us to inject data into our database. So that's a very simple one. And for example, what I can show is integration with this part. So I can go to my browser and I can show you the page of our app. It's a data set from F3, and it has okay, well, so we have root node, which is center in the middle, and we have one upstream, and it's connected via Spark. So let me increase a little bit. Yeah, so it has one upstream, and it's icon shows that it's connected via Spark, so it's a kind of strong Spark integration. If I enable column level lineage, we can see they also connected to each other. There is 3 columns in each table, each connected to each other. But right now we can go back to Spark job, make some changes, and it's going to work in real life. So right now, this data, I can start from the beginning. So right now we have Spark session, and we use AWS Glue as a meta store. So we set up the Spark job, and we use Spark SQL method to actually execute SQL inside Spark itself. So we create some database from data that we already have. It's a CSV. We populate it, then we create some tables, and we create column level lineage between them. So we create tables and create corresponding connections. So right now, is it what you see in UI? Right now, I'm gonna add one more join table to our Spark job. And I hope it's gonna work, because for today, it also was an AWS outage, so it didn't work properly, but I hope it's gonna work fine. So right now I'm gonna run the job. And eventually, yeah, so what it does, it just create that Spark job on AWS Elastic MapReduce, and it's gonna run it for maybe 4 minutes. Let's check if it's up and running. Okay, cool, it's pending. And since it's pending, I guess I'm gonna talk about more about our lineage UI implementation and how it works. So still we have like 4 minutes left. I can go to a different page with more comprehensive lineage. I can go to full screen to show you everything. So that example for Spark, just 2 data sets, is very simple. But in a real world example, lineage can be huge and very, very complex. So this feature, I guess, is one of my favorites, because kind of it bands together a few core concepts. For data management, we use Graphology library. It's basically graph implementation from JavaScript. And we use VisX library from Airbnb. It's a set of low-level SVG components to actually view the UI. But it's only drive entire logic, but everything else is viewed by us using SVG and our design. So this lineage is called showing kind of data flow from left to the right. So that's why it's a direct graph. So you can see each node has some upstream and downstream. Interaction shows how data flows. You can expand any given. Yeah, our session in our different environment is shorter, so I will keep off. I need to log in again. Yeah, but this is use.
How you know this is an authentic demo?
Yeah, you saw our like cool login page. Okay, not this one. So I need to go to phone and find my invite price. Great. Go to page. So you can expand lineage further if it has any downstream, for example, and at any given point you can also collapse it. Yeah, you can also collapse it. For the layers of lineage itself, as we showed before, it can be column level lineage. So it can enable for the root node, which we by rights, and connects all column lineage available, which connected to that root node. So you can see immediately it's going to be very busy, and that's why it's crucial to understand how data lineage for particular column lineage works. Yeah, it's not even harder one. There is more complex. Also, you can enable, we talk about transformation. So lineage talks about transformation, how data transforms when it's slow the organization pipeline. So you can say enable transformation for this one. And for integration for data sets, right now we have DBT. So you can notice some DBT datasets has on top DBT models, and there is edge icon indicating that DBT model materialized as Snowflake table. And of course, it works both directions. So if you go to DBT itself, the dataset going to be shown like a transformation layer for DBT. And last but not least, it's impact analysis. So make sure that data, you don't like, break anything if you make some changes. There is some indicator for impact analysis. What's the usage for this data set? How many people follow this data set? How many tags it has, or how many unique views that the data set also has. Okay, so let's go maybe do this job and check if it's okay. It's still running. Yeah, I guess I can talk more about OpenLineage integrations. Yeah, so I guess you also talk about what we already have. It's partnered now, but for integrate expectations, it's coming soon. For DBT, we already have our own flow crawler, and it's open source, so you can go to our webpage to connect us and probably use DBT integrations. Yeah, let's check one more. Cool, it succeeded. So as you can see before, we had only 2 datasets connected to each other with some column level lineage. I'm gonna open new tab and it refreshes this dataset, and we're gonna see more stuff. So I just expand. Boom. So we have one more table, and if I enable column level lineage, it's exactly what is specified in Spark job. So these column level lineage is a new, it's a name and phone code. If I go back to Spark job, it's all specified. It's on one more table join, and this piece drive our column level lineage, which was added. So just in real life, it took a couple of minutes, and it's going to be live. Yeah. So where can I go next? Live demo with Emmet, and I also want to invite you to talk about more about Meetup itself. So yeah.
Yeah, so because lots of you haven't heard about Meetup before. Yeah, so this is the data set community page metaphor. And right now, obviously, you can say the page is fairly empty. So, if a data consumer comes landed on the page, like what he's looking at, he probably has no idea. Right? But as a data producer or who has knowledge about this data, right, we can say like add a description to help people like at least know like what's the data about. And also we have this AI button. We can help the AI can help us or help the data producer to generate the description based on the nature of the data. Yeah, so that description, and you can assign government tags. Yeah, so to make this data set basically all well organized and easier to find. You can also assign contacts. So we have me as a contact and multiple people. So with the contacts, and this the consumers, if they have a problem or concern or question about this data, they know who can answer the question. Who they can basically reach out to. Yeah, so with this, the page right now is already fuller. It can make sense like what the data is about. And also another main feature Metaphor has is for the posts. So you can say all the posts right now related to this data set is on the right side panel. Yeah, so the main purpose of the post is to capture knowledge about the data set itself. All the posts created on this page is basically anchored to this data set. So when people read the post, they know, okay, this is talking about this data set. Yeah, and you already say, we can like and also comment on the post. So the reason why we have the post is because in Metaphor we believe a lot of like previous generation data catalog missing the social context of data. Most of them basically fundamentally they are just a data engineering centric view of the whole world, right? But for like most of the data consumer, like who make a business decision, make a sense of the data, what they need is just a simple indicator of trust. can I trust this data? Is this data accurate? But how they can basically find like who can help? Right? What is the context? Why we have this data here? Right. So we created a post to gather basically the data producer and data consumer together on this data. They can basically say write capture their knowledge, raise concern, comments, or even approve, right, and find the help on this. So so basically in general, both parties get together, like work collectively on data, and we truly believe this tool will make data work for people.
Great. Yeah, so yeah, that was the demo. So if you have any questions, yeah, we'll be happy to answer.
I have a question about the transformations page.
Yeah.
Tell us how you gather that information and how you like sense of it. Like, what I would say is like you connect the jobs with tables, right? And
It's a for Spark, right? For DBT, we have our own connector.
oh, okay, it doesn't work with OpenLineage.
Yeah.
Do we have an idea to use it OpenLineage, or they want to like in advance with?
I guess like we spoke before, like before this demo, also talk about like why we didn't use DBT. Probably we like way back in the beginning, we integrated with DBT and did ourselves. And also, as I know, probably DBT integration for OpenLineage, as I know they have some wrappers around DBT. Which is kind of not for DBT implementation, so we want to get like everything working yet. So probably we're gonna use like our own connectors.
We have the DBT integration before you took this over.
Right, but could you like use Spark integration, for example, to generate this page, or is there like some special data that you can get using OpenLineage integration, regardless how it's implemented right now?
Yeah, for Spark, it's only for demo purpose. We have this one, so it's not even like in production one.
Okay.
So created like before demo. Yeah, want to do it like Airflow. When you have enough time. So yeah, it's not like in real life for Spark, but for demo purposes, but probably for next meetup, yeah, for sure we can show both.
Right.
Yeah. Any other questions? Cool. Then yeah, thank you so much for your attention today. So here is you can find more information about Metaphor. And you also can get free phrase flag. It's on the table. It's stickers. Yeah, thank you for hosting us today.
Thanks.
Thank you.
Thank you.
And perfect timing. The pizza is here, so this is time for the break.
Nice.
And feel free to chat over this.
Sure.
So I'm looking on market. Yeah. So if you check like around because the brand operations database and we were talking about for another database on and way to like no matter what. Yeah. We were running 5 minutes. Yeah. So curious. Like
everyone, we'd like to So before we get back to talking about lineage and the rest of the presentations, first, shout out to Michael for organizing and taking care of everything. And of course, thank you everyone for our speakers, Julien. Before we start Paweł's presentation, I'm just curious, show of hands, who is a Toronto local? Okay, wow, nice local audience. Who is also attending Airflow Summit? Okay. This is just me being curious, and warming up. So, who's not attending?
They are specific.
Well, we can do them out.
So I was not.
If you didn't listen, you can go copy homework from a friend, okay? Or ask GPT, I hear that's what.
I don't care. I'll throw a razor from the back of the room.
So yeah, I think it was the most mentioned person actually.
All right, Paweł.
Hello, everyone. I don't have any slides prepared. I'm Paweł. I'm a software engineer at Getting Data, and I work at OpenLineage for 2 years. Together with Maciej and Kuba, we were Getting Data, and I was working on Spark integration. The Flink integration is something that we've done together with Maciej. I was contributing to Marquez and worked on the OpenLineage proposal. And yeah, I really like the presentation before, the metaphor guy, that we like Spark integration. And I think it's a cool thing because, you know, OpenLineage makes sense if you call it the cross-platform lineage. And, you know, Spark and some SQL, I think it's a common scenario, common use case within companies. And you would really like to see the lineage of the whole company, or some guys using SQL, query, REST, whatever you call it. And some other guys expressing things in Spark, and then make it an overall lineage of what's there. Who of you has used or tried the OpenLineage Spark integration? Okay, that's great. What was your experience? Because I want to start with a few questions, because what's difficult for us is getting the right feedback and getting the right feedback on what should we focus on, what's important for the project. And if we do Zooms, then people are not perhaps that willing to chat, to talk, because it's difficult to talk through the Zoom. It was like milliseconds away, and now we are here in a single room, so perhaps it will be easier. I don't know, would anyone like to share some experience, with on docs, OpenLineage and Spark, to try to do something and did it work out of the box?
No, I can share some information. Yeah, I got a possible message from our backend developers. Yeah, basically told me in the beginning he wants to use Spark just by their class, and the ticket route to Java with the Spark job before to Spark who wants to route, and he needs to understand deeply what's something. Yeah, API is to make the job. Yeah, so later we on the OpenLineage, which has Spark already. So OpenLineage the field is everything, and the distribution is Spark. Very quickly.
Okay. Okay. And what versions of Spark are you interested in? Some specific versions of Spark?
The version Spark. I would do what's Spark version.
Yeah, because that's an interesting thing, because if we're doing some demo, it's always good to get the latest one and try the things out. But if there is some company that would like to use it, then perhaps they not only have the latest versions. In most cases, they have all the versions that have been seen to the ancient history of their data processing stuff. And that's something I want to ask in another question, because a few days ago, Spark 3.5.0 was released. And so far we thought, hey, let's support the 3 latest Spark versions. So we do. What does it mean for us to support it? It means that our CI does the integration test of the integration against those 3 versions, yeah? And so for today, it's 3.4, 3.3, 3.2. And if we decide to support 3.5, we need to get rid of one of the previous ones, or we can leave it. And I don't know, does anyone have an idea if it's okay to abandon 3.2? Or shall we keep the integration test for it? Yeah.
Yes.
Yes, because the funny thing is that it doesn't mean that much work to us to making sure that the older versions are up and running, that they are working. But it requires, the CI being run, that there is something that has to be done, but it's not a lot of work. So, if we're able to know what the people want to use, that would be, I think, helpful to us either. Okay, and there are more such questions like, would you like, so for now, if you have a Spark job that reads from 3 data sets and writes to 3 output data sets, for OpenLineage, it's treated like 3 different Spark jobs, because each time we write to something, it's a separate Spark action which we treat as a separate job, and it has its pros. It's cool, but I mean, some people may not like it or prefer to do it a different way, because perhaps some may want it to have to be a single job, no matter how much lines of the code you have within it. So yeah, feedback on that would be also helpful. And actually, even if you don't have anything to be said now, if you don't want to talk now, please try to be active on our Slack channel, because we're the community, everyone can raise an issue, and if you raise an issue, it doesn't mean we'll work on it tomorrow or this day in the evening, because better things to do in the evening. Like, no, it's not the topic of the presentation. Okay, what can you do in the evening? But the point is that from my side, as a developer working on a project, I would really like to have a feeling that I'm working on the most important things. And if someone on Slack channel writes, "Hey, this thing is not working," and then 2 other guys say, "Yeah, you could do something with it," then it would mean for me, oh man, that's important. And because otherwise, my perspective can be wrong, and I can say, oh, some corner case, let's leave it, yeah, let's leave it, and let's see happier later. And yeah, so this leads to funny cases, because it's even hard to say what's the adoption of the Spark. And do you know how do I know how the adoption works? So because at the beginning, we used to make, I'm a developer, I make errors, then I fix it, and then this is how the story goes. And a year and a half ago, we had a Spark box that made it unusable. Like we introduced something that, you know, that was breaking the things because we didn't test it in that case. And there are people like writing on a Slack channel 3 weeks after the release, hey, I think there's something wrong with it, yeah? And we saw, oh, it's wrong. And it was a nightmare because, you know, first we introduced the bug, and then it turned out it took just 3 weeks. It took 3 weeks to find it out. And when now people do raise an issue, it's more like a corner case. I'm doing a complex SQL query with an old Spark and Iceberg version from 2 years ago, and you know, one output data set is missing. Yeah, so that's how we judge if you know our job. Yeah, if it's done okay or no. So at what level is the adoption currently? We see what are the questions raised by the people, and if those questions and issues are really complex in corner case, it means we are moving far away from those entrance ones, and the simple things have already been fixed. Some time ago, we introduced the column lineage, and it started off with the proposal 6 or 7. Oh,
Like PR 647 using one.
yeah. So it's a proposal on what should be changed within a spec, OpenLineage spec, to support it. And if you show the example of the, so there's a column lineage. You don't see it because it's too small, but we can track from it, and if not, I can read it. Reading the slides to prove fun. So the story started on how would we like to express the column lineage, because column level lineage seemed to be pretty cool and the missing feature to lineage platforms. And I think initially we started with, you know, that's the way we would like to express within a spec the column level lineage. And I remember I showed it to Maciej, and his feedback was like, why don't we create a facet to tell that there should be no wars in the world, yeah, or hunger should be treated. So I mean, what the standard didn't make sense at all. So it's not the point to invent the spec that describes how column lineage should be presented. The crucial thing is here, what are you able to extract from the queries, from the data processing jobs? You're given SQL or Spark job, what can you extract out of it? And and the feedback was, let's not merge this PR, let's try it with a proof of concept, trying to find out what's doable. And and we jumped into the Spark code base. And actually, our Spark integration is cool because, you know, we attach the jar to the running Spark job, and we can execute any code we like attached to it. So we do have an access to a Spark logical plan. So if you're working on data frames, data sets, or write a Spark SQL, you call an action because Spark is lazily evaluated. So it first creates transformations, and then at some point it triggers an action which evaluates it. And this action is presented as a logical plan, and which is actually a tree. its root node is an output data set, then there's a whole tree of what you defined, and the leaf nodes are the input data set. And before column lineage, we were able to, traverse the whole tree, identify the root node. This would be the output data set, the leaf nodes, which are the input data sets. But we had no way, how the leaves affect the roots of the root. And are we able to track the dependency between the expressions? And how much work is it? Because, we're afraid that if you look at Spark SQL functions, there are like 100, 200, or 500 of them. And if we had to cover all of them to provide column lineage, we'll never do that. And once we did it, it wouldn't be up to date anymore. Because there's so much of this. But what we found out that although there's a lot of code within the Spark, there are some structures, some patterns that we can use. And for each node within a plan, we can identify what are the input fields and what are the output fields, and which one depend on another. And that is the interesting finding, because this allowed us to solve this problem regardless of how big is the logical plan, how complex is it, as long as for any type of the node we can detect its inputs, output, and how do they interact with each other, we can build column lineage out of that. And it turned out that there are not that many types of the nodes within the tree, like aggregate, projects, perhaps a few more, aggregate by something and so on. But it's like 5 to 10 of them. And and this allowed us to prepare the proof of concept for Spark. And once it was working, we had an integration test for that. We could proceed with the facet within the OpenLineage spec because we knew it's durable. And that's the cool thing about OpenLineage, that we say OpenLineage is just a spec. It's not just a spec, it's just a spec verified on the real use cases that is applicable, and you can, out of the box create such lineage plans. And that means much more than that. Later on, so we knew that Spark plus some SQL, that's the combination of technologies that are common in many stacks, that would like to also extract column lineage from the SQL. And then again, Maciej is the guy with most brilliant ideas, or let's say brilliant ideas. And he came from the news that there is a great third-party SQL library, SQL parsing library, which is written in Rust. And we were like laughing for 30 minutes. Maciej, why Rust is better than Go? I mean, we're laughing because we didn't understand what are the benefits of applying Rust here. We do have Java in our stack. We do have Python. Yeah, you can fit anything you else like into it, but what's the reason in doing so? And so third-party library is called SQL Parser Res. It's really it allows really rich SQL syntax. So it's capable of dialects. And if you look at that code, so I didn't program in Rust before, but it seemed to me really cool how many things can you express with so limited amounts of code, even if you don't know the language. and which I found really great. And what is the benefit for us in OpenLineage as we're using Rust? Well, because we needed something that is capable of parsing SQL that we can apply for both Java and Python world. So for Python, because we're heavily integrated with Airflow, and triggering SQL from Airflow is a really common use case. And for Java, because within the Spark integration, within the Spark you can call some SQL through Spark JDBC, and having the single parser would be great. So that was the cool thing about the Rust, and that what Maciej did. So he bundled the SQL parser library in a way that we can use it from both Python and Java. We do have clients for that. And there was also a guy who contributed to extract the column level lineage from the SQL within that library. And it's an open source library. And we found it cool because we were able to extend it. So we got the users that use Snowflake, and in Snowflake there is things like copying or create stage, which are not the part of the SQL standard, but they're really useful. And people need to take just the files and extract data from them in a SQL way. It allows a lot of more SQL scenarios, and so we added the support for the syntax within the SQL parser, and actually can extend it even more. And I think it's a combination of great features, SQL plus Spark, being able to extract lineage and column lineage out of this. At some point, we added transformation type. I think it's Julien had this. So we wanted to describe, because there's an output field, and we say, hey, these are the input fields that were used to produce it. And we wanted to make it more descriptive. Okay, but how did those fields were used to produce the output field? And we've added transformation type. Actually, two fields. One is like human readable, put anything you like. The other one is transformation type, because the important use case for this is PII data. Be able to find out where do you have PII data within your organization, and in some moments people do some masking caching of the personal data because they don't need it anymore for their machine learning AI or call it stuff. So we wanted to have a marker so that you can mark, hey, after that point, downstream data sets do no longer contain PII data. We introduced, some markers like mask identity to notify it's a direct copy of the data. And recently we have found some limitations of this approach. Like we've introduced transformation type. Perhaps we did it that we could do it better so that it's not on the level of the output field, but it should be on the level of input field, because they can have different transformation types. The other thing is, what does it mean for data to be masked? Some claim it's not accurate enough, and it's okay. It's right, but it's really difficult how to make it more accurate while still leaving some option for other users. So I think there is a further work that's going to be done with the column lineage. But we're already pretty happy with its adoption and with the amount of issues that people are rising in the GitHub and how extensive those issues are. I mean, like, if you're an author of such code and you see an issue, its whole lineage is not working well for merge into commands on Iceberg. I'm always happy with such issue because it means that it works for the basic scenarios. Perhaps it works for merge into, but if merge into is run on Iceberg, then you are having such issues. And if you reach that point, it means you needed to reach 10 points before, and you should have succeeded with them because you were asking at the level 10. So that's nice. And yeah, I think I'm actually done.
Any questions? So I will be talking about OpenLineage in Airflow.
Did I say Maciej is brilliant?
So it's great that most of you won't be at Airflow Summit because I would spoil the presentation there. Can I?
You want to share your screen?
Yeah, I want to share my screen, and I hope it will work. I don't want. No, that's not what I want to share. What I want to share.
Make sure you unmute.
Yeah. So okay. Let me. I need to make sure that I'm sharing everything, not just the. Oh, yeah, that's good. Is it working? So okay. So let me start to showing you how to use it. And first, so since Airflow 2.7, the integration is part of Airflow itself as Airflow provider, and you can use it by basically using official Docker Airflow image, which is where it creates all. So to use it, if you just install it, it doesn't do anything because you need to configure it. And to configure it, you basically need only to tell it where to collect the events. So this Airflow config, right? You have to put your transport configuration JSON in string type, and this configuration actually just means you send HTTP events to this market instance. There are more configuration, like you can tell it in which namespace to send the events, which will be used in the job namespace. You can disable it. You can put your additional extractors, which are kind of legacy feature for this provider. But if you used OpenLineage with Airflow before, you might want to use it. You can disable it from source code for Python and Bash operators if you want, and you can put config path if you have configured it in some different way. So let me run a quick demo, and I hope this will be the first possible demo because it's so easy. So I have nothing in Marquez, and I hope next time I can use metaphor here, for example. And I have some random DAX, right? Let's run a DAC, and I hope it will work because I have a nasty habit of using actually development version of Airflow and from main, so something might go wrong. I'm running some Snowflake, very basic Snowflake DAG, and it ran 2 times because I had DAG stopped and run it. I haven't
I don't have anything here, right? And now I have some data, right? I have a graph, and that's basically the demo. So I have a very screenshot version of it here. So how does it work, right? Basically, our idea is that each operator in Airflow exposes lineage themselves and maintains the contract itself. The lineage contract is exposed by the data structure that we provide in the provider. And so by using this way, where the code is not some external thing to the operator code itself, we are ensured that it will keep up with evolution of the operator, because we test there that guarantee that the implementation is secure. It makes sense, right? And then if you change it in a way that will break it, you will break it. You will see the tests. Somebody, if you push it to the Airflow repo, it will break there, and nobody will measure PR until you fix it, hopefully. So it looks like that. For example, this is BigQuery to GCS operator, and it's simplified version of it. But basically, what you need to do is implement one of those methods. There's a get OpenLineage method to start, complete, and a failure, and they cover different states of which your task can end up. It starts, right? We send an event that the job started, it completes or it fails, and we send an event about that. We basically take, in this case, some UI where we copy the data from BigQuery. We take the BigQuery data set as an input. We'll put the Google storage output, right? And so how does this structure look like? Basically, a list of inputs and outputs and run facets and job facets. It's not an OpenLineage event, as you would see in.
Sorry, it's my commitment.
Yeah, it's not a full event that you would see in your like OpenLineage backend, or if you wanted to create your own implementation. Why? Because we want to attach some facets ourselves in like the Airflow provider, because we have some meta information that is useful for every event. It wouldn't make sense for every operator to basically do the same thing ever and ever again. So we'll use this feature and it will work. Right. So outside of this, we have some common parts to the provider. It's basically we are called by the Airflow feature called listener API, which basically notifies this start, complete, and fail states. We check if the operator has some lineage implementation, right? If it doesn't, we do some default thing. We call the methods, and we enrich the data with the common facets. So yeah, we also have some additional part there. We provide some additional utilities that you can use if you want to implement your own implementation of OpenLineage operator, like the SQL parser that Paweł told us about. We provide DAG monitoring, so we send an additional events for like start of DAG and complete of DAG that are like used as a parent of all those operator events. And we provide backup mechanism. If you use like older Airflow's lineage mechanism, we use those this lineage if we can get it automatically. So there's a backup mechanism basically. So yeah, if you're creator of operator, what would you do? You have to define the methods in the same class as the rest of the code. Why? Because, as I said before, it makes sense to test together, and you can encapsulate data that otherwise be public inside your operator. So, yeah, before I say what does it mean, I want to say that not everything needs to have lineage. There are hundreds of operators, and most of them are dealing with data, right? But some of them, like Slack API operator, is used to push notifications to Slack, compound Slack, or you can create a bucket, create some VM, or do something like SQL HTTP operator which just calls some endpoint, and we have no idea what actually it does, right? It's very generic. So I don't see a point to implementing this. You can if you want, but yeah, it doesn't make that much sense as some other else. So how does it work, right? So we get called and start before the operator's execute method actually runs, right? And then either on complete and on failure facets methods are run. Why does it matter? Because some data is set up on operator only on execute method. So for example, in this case, we have some job ID that we got from running query, basically. You know that it runs in SQL, right? We get the job ID, but we don't get the job ID before we actually executed the job, right? So we can't get the lineage on start. We only can get it on complete. This matters because we sometimes can get the additional metadata in complete, right? Also, that some data like processing, amount of bytes processed, or amounts of rows returned, stuff like that can only be done on complete for obvious reasons. So it makes sense to have different methods sometimes, sometimes not. So what we don't want to do for operator creators is like get actually the metadata prepared for on execute. So we want to store the data like .id and do the actual work in OpenLineage methods. Why? Because it can be heavy, right? Or if not heavy, then it can like have some network calls. If somebody doesn't have lineage configured, your work done in the execute method will still be executed. So you will do some work that will never be used. And by doing this in the operation methods, if user doesn't have them configured, it will never run. So we avoid some work that wouldn't be necessary. So, and the last part, what we'll do in the future. So first, we need to cover more operators, more providers. There are still tons of operators that aren't covered, right? And we want to do this. We ask community to help us with that. If you maintain some provider operator, consider if you want to contribute this support. We will help. We also want to add support to more, right? There's still a lot of ground to cover. Second, we think about integration with IP48 datasets, because this is a cool feature that isn't used, that basically hasn't lived up to its full potential yet, right? If you have already set up data set IP48 datasets, then we don't take advantage of that, right? We have data-aware scheduling, but the data lineage mechanism doesn't know about it. It would be cool to have this covered. In the other way too, right? If you like use data-aware scheduling, but you don't know that the data set is being updated somewhere else, you're not also using the IP48 to its full potential. And I think there's a lot of common ground here. Second is like Python operator, right? Python operator is most used operator in Airflow, I think. I'm pretty sure that's true. If anyone has other data, then feel free to correct me, but it's not covered. Why? Because you can execute arbitrary Python code there. And the task flow is also like Python operator underneath, like actually something like underscore Python wrap operator, but it's the same. So what we think to do is to add support for hooks, and the hooks can track their own lineage, right? If you use like, I don't know, BigQuery hook or Snowflake hook, they can do basically the same thing that we did. So save some usage information, and then Python operator would look at those used hooks and basically take their lineage as their own. So we would have support for the case where users are actually using hooks. If you're still using like arbitrary Python code, right? You want to probably add some helpers. We also need to like more think about this more, but it would be nice if like you could emit your own lineage more easily if we don't cover that already. So the same goes for, I thought I have another slide here. The same probably goes for like Kubernetes pod operator and Kubernetes related pods. And basically, if you schedule something somewhere, then we probably can do a better job than we can do now. And all of this can happen because OpenLineage is in Airflow, and otherwise it wouldn't make sense because we can do this from the outside. Thanks.